Okay, solve equations by factoring. What you did last week was we had problems that looked like this, and we said, okay, we know that there's multiplication going on here, and the rule for multiplication as far as 0 is concerned is that all I have to do is have one of my factors be 0 for the product to be 0. So we made basically two separate equations saying that I needed this one to equal 0, and I also needed this to equal 0. Remember? Because either one of these equaling 0 times the other was going to give me 0. So I said, okay, divide both by 3, a equals 0 for this one. And here, subtract 2 from both sides, a equals -2, and I had two solutions. Plug either one of them in, and we get 0. Plug in 0, and 3 times 0 is 0. 0 times 2 is still 0. If I plug in -2, -6 times 0 will still equal 0. They both work. They're both possible solutions, okay? But that was already in factored form. For today, we're going to solve the equations first, put them into factored form, and then solve them. X squared minus 9 is equal to 0. The first thing we always want to look for is GCF. And that's not going to change. If we're going to factor anything, whether we're trying to solve an equation or we're just trying to factor, we always want to look for the GCF first. Is there a GCF between x squared and 9? There is not. Is this something that's familiar to us, or we can call it difference of squares? Difference of squares was x minus 3, x plus 3. So now, basically like we just did before, is I'm going to make each of these sets of parentheses equals 0, and then solve. So for this one, we're going to add 3 to both sides. X equals 3. For this one, we'll subtract 3 from both sides. X equals -3. Any question there? N squared minus 3n is equal to 0. First thing we always want to look for is a GCF, right? What is the GCF here, Marlia? N. They both have n in common. I'm going to pull the n out. N times what gives me the n squared, Marlia? And n times what gives me 3n? 3. This n will equal what? And this n will equal 3. Those are my solutions. Okay, let's give you one. Let's give you one to try here. GCF, and it is. What's on the inside? This x will equal, this x will equal, and there we have it. Well, this is about, for some of them you'll be able to solve with GCF. For some of them you'll be able to solve using difference of squares. Some of them possibly a combination of GCF and difference of squares. Some of them maybe perfect squares, maybe with GCF. So there's a lot of different ways in which we can see these. These are about the ones I'm showing you now are about as basic as basic gets. What do we do in a situation like this? How is this one different than any of the other ones that we've worked with up to this point? Usually, they equaled what? 0. Is there a way in which I can make this equal 0? Can I move anything? What should I move? What kind of 144 is it, positive or negative? So the opposite, if I'm going to move it, I'm going to subtract it from both. If I want to get rid of it over here, Marlia, I want to subtract it. But if I subtract it from that side, I also have to subtract it from the other side. What's left over here is now 0, 144 minus 144. Okay? So now, let's check. First thing we always want to check is GCF. Is there a GCF between y squared and 144? No. Are there two terms? So we can check for difference of squares. Yeah. Y minus what? Y plus what? 12. Solutions? 12 and negative 12. Okay? Now, we really have only worked with, this one has 3 terms. 1, 2, 3. The only concept that we've worked with that dealt with 3 terms was what? Perfect squares. So here's where we say, is the first term a square? A square of what? A. Second question says, is the last term a square? Square of 9. And that middle one, is it 2 times A times 9? Don't worry about this yet, because we'll take care of that. So if the answer is yes to all 3, what we have is A, is it plus or minus? Minus squared. Okay, do you vaguely remember this? Okay. Now, where do we go from here? We need to solve this now, right? It's going to equal 0. So what do we really have if it's squared? I've got A minus 9. A minus 9. There's 2 of these, right? There's 2 of those. A equals 9. Do I need to put 9 comma 9 if it's the same? No. Square. It's not difference of squares, it's a perfect square. Okay? Difference of squares just like a squared minus 16. Okay? perfect square has the 3 terms. How do you check it? How does this make sense? We say a equals 9. Let's plug it in. 9 squared minus 18 times 9 plus 81. What is 9 squared? 81 minus what's 18 times 9? 162? So 81 minus 162 plus 81 equals 81 minus 162 is negative 81 plus 81. Does it equal 0? Yeah, so it works. So essentially, that's what we're finding out. We're finding out what can we plug into this equation to make it equal 0. And we found it. I don't know how that's going to help you at the grocery store or anything like that, but algebra is all about problem solving. So you can start with something and get something from it. That's awesome. Try this one. All right, so when we have 3 terms, like we do, the 3 terms being m squared, 10m, 25, first thing we want to look for is what? Yes, GCF. Then, since it's 3, we'll look for perfect square. First term of square of m. Last term of square, yes, of 5. Is my middle term 2 times m times 5? The answer? Yes. So, I'm going to get m. Why is it plus? Because that's plus. M plus 5 squared equals 0. M plus 5, M plus 5. That's what this really means if they're squared. M equals negative 5. Got it? Got that. Is there a, well, let's first of all, let's move this 50 over to the other side. Now, first thing we look for, GCF. Two terms, difference of squares. Okay, so my solution, I don't have any variable out here, so it doesn't really matter. I'm not finding a solution for out here. There's no x with it, so I'm working with these. X equals 5 and negative 5. Yes?
I didn't think it was right because 2 times a negative 25 wouldn't that equal positive 50?
2 times a negative 25. No.
Oh, yeah.
Positive times a negative.
I was thinking of square.
Okay. Can you check it? Plug in a 5. 2, 5 squared. What is 5? You do the exponent first. What's 5 squared? 25 times 2. 50 minus 50 equals 0. How about negative? Negative 5 squared. Negative 5 times negative 5. 25. Times 2 is 50. 50 minus 50 equals 0. Okay, so take a look if you had any confusion at all. Do we have a GCF? No. Is it difference of squares? So we should have 7x minus 10
7x plus 10 equals 0.
Okay? Do we get stuck here?
Why? Each of these get turned into their own equations.
Right? So watch. To get rid of the negative 10, we do what? The negative? Divide both sides by what?
X equals 10 over 7 or 1 and, okay, here.
Get rid of the positive 10 by doing what?
Divide both by 7. X equals,
It's fine. Do you need a decimal? Can you keep it in the fraction form? Yeah, keep it in the fraction. It's so much easier just to keep it in that fraction form. Anything is a possibility. You cannot limit your thinking into that it has to come out a certain way. It is, as they say, what it is. I hate that expression, but it's true in this case. I hate that it is what it is.
Of course we're going to get close to that.
I hate it.
Yeah, Steve.
Difference of squares? Yeah. Very good. Then
we make these their own equations equaling 0. Okay, so here, Marlia, we're going to add 3.
Yes?
Divide by 5. X equals 3/5. Subtracts, so divide both by 5. X equals negative 3/5.
Yep.
So, wait, what if I had the negative 3 over 5 on the left side?
If you had this as your final answer and we didn't, then you lucked out, then you were fine. There's still both solutions. It doesn't matter which one goes first, because if you think about it, I could,
Marlia, I could make that one plus.
that one minus, it's still the same thing. Can I multiply in any order?
Is this what's happening here? Multiplication?
2 parentheses jammed up next to each other. So it doesn't matter if I have the, so your answers, I mean, it matters, Marlia, because you didn't do it right, but it doesn't matter if those what you have as your 2 answers, because that's what they are. Okay, if that makes any sense to you. Look at page 197 and 1 through 30. Are there any in 1 through 30 that you look at and panic? Well, maybe we could just do class during recess today then, if you don't have it. 17? Yeah, go ahead.
All right, let's set it up.
How am I going to get this negative 36s to the other side? Add it.
So I should have equals 0. Then,
First thing I always look for, GCF.
and between a 4s squared and a 36s,
It's what?
for what? So then, s plus 9 equals 0. This s equals 0. This one equals -9. How many of you looked at the 4s squared and the 36s and said, oh, difference of squares? No? Well, good, because it wasn't. Any other ones? Sure, 21. Very similar to the one you just did. Hint. GCF.
You guys.
9 what? 9x. Then x minus 4. This x equals 0. This one equals 4. There are your solutions.
Get it? Marlia? Yeah? No. All right. $26? Why?
Fine, 26. Last one.
Stalin. All right, so Marlia, what are we going to do with the 121?
Leaving me with 0 on the one side. Difference of squares? Whoops. Good. M equals 11. Negative 11. Either way, either order, doesn't matter. That's what the solutions are, right? Good. All right, page 197.
2 through, what do we do, 26?
24. Even.
If you see 3 terms, you're going to want to check first of all for what? Right, always check for GCF first. If it's 3 terms, you're checking for perfect square. 2 terms, you're checking for
Difference of squares.